So in this video, we'll be focusing on histograms and going over an introduction about what a histogram is, the difference between a histogram and a bar chart, and go through the steps of being able to draw a histogram from a group data table. Now, a histogram is a statistical diagram used to represent group data, and that's the key point of the fact that a histogram is used for group data only. Now, though it looks very similar to a bar chart, it is one, drawn differently, and two, read differently as well. Now, getting confused between a bar chart and a histogram is why a lot of students tend to find this topic difficult. Now, before we get started on a histogram, let's just have a quick refresh on bar charts. So as you can see, we've got an example of a bar chart. So the bar chart shows the number of visits 14 people made to a supermarket in a week. Now, the key principles of this particular bar chart is that one, it's only used for what we call discrete data. Now, that's quite a high level mathematical word, but basically discrete data is data that can only be certain numbers. So for example, you can't visit the supermarket 1.7 times. You can't measure it, let's say, 3.2647 times. So it can only be certain numbers, nor would you expect someone to visit a supermarket, I don't know, 3,426 times in a week. Or even if people who work there would only visit it 7 times on regularly anyway. So again, it's certain numbers within a given range. And also a bar chart is used for what we call categorical data or worded data. So for example, you'd use a bar chart if you were representing data of people's favorite color, or people's favorite subject, or people's favorite sport. So things where the answer is a word, then that's where you would use a bar chart to represent the frequencies of the responses. Now, for that reason, as we kind of mentioned, that bars must have equal gaps in between them. So for example here, because you can't have decimal answers or answers between the numbers, that's why we leave gaps between each of the bars so that people do not get confused between the two. Now, these gaps need to be equal. I know that this gap, the first gap, isn't equal compared to the others. First gap's kind of a pass, so you can get away with that, but in terms of the gaps between each of the bars, they must be the same. And likewise for the widths of the bars, so these widths of the bars must be the same for each bar that you draw. So what you don't want is one thin bar and then one kind of chunky bar. And the heights of each of the bars are based on the frequency. So again, looking at this and looking from this particular bar chart that we've got, is that however many people have chosen that response is reflected by its frequency or the height of the bar. So for example here, the most popular number of visits to the supermarket by these 14 people was 0. The next popular was 2, then 3, and then 1. So 1 was the least amount of times that someone visited the supermarket. Now, which doesn't quite work in terms of because 0 is, but again, yeah, hopefully you know what I mean. Now, and so the main principle of a bar chart is that the height is what is represented by the frequency. So whichever bar is the highest, that one is the most popular option that people have chosen. Now, a quick comparison, let's now have a look at a histogram. So the following histogram shows the weight of apples in a box. Now, let me just say, as you can see, we've still got bars, we've still got axes, we've still got graph paper. So let's have a look at the key principles of this particular diagram. So the first one is that it's used for grouped continuous data. So grouped is basically where the data is grouped. So you've not got individual results, you kind of fall into a numerical category. And also continuous, which basically means that numbers can be any number within a given range. So that's the main difference. So discrete can only be certain numbers within a given range, whereas continuous data can be any number. So for example, you could have a apple that weighs 137.267,48213 grams. That's absolutely fine. It all depends on how accurate your measuring machine is. Now, as numbers can be any number within a given range, there are no gaps between the bars. So again, you'll have no gaps. Now, the only time that you may have a gap between the bar is if there is no one in that particular group that you've chosen, in which really you shouldn't really be including it in the data. So for example, if there was no one in the 140 to 160 range, then this bar would cease to exist. But then if that is the case, because you shouldn't really have gaps in a histogram, what you tend to do is, rather than having a group of 140 to 160 equaling 0, you would simply include that in the 100 to 160 group. So you don't want to have any gaps, and that would be one alternative way of avoiding that sort of situation. And the next thing is that the height of each bar is based on the frequency density. Now, the key thing to note here, and one of the main properties of a histogram, is this, the frequency density. So in a bar chart, we had frequency along the y-axis or the vertical axis, whereas in a histogram, we have what we call the frequency density. And again, we'll talk more later in the video about what that frequency density actually is. Now, in a histogram, the bars can be unequal widths if the grouping range is different. So for example, here you can see that the widths of each of the bars are different, and that is absolutely fine because it all depends on the groupings of each of the categories. So this group here is 100 to 140. This group here is 140 to 160. This group here is 160 to 180, and so forth. That's 180 to 200, and the last one is 200 to 240. So you can see how the widths are different. This one's got a width of 40, this got a width of 20, 20, 20, and 40. And one of the main principles of a histogram is the final one, which is that the area of the bar represents the group's frequency. So in a bar chart, it was the height of the bar that represents which one's more popular. In a histogram, it's which bar's got the greatest area, which will have the highest frequency. So for example, now this is what the challenge is in a histogram, it's not really designed for you to see which one's more popular. It tends to go into more high level statistics. So for this, you kind of need to decide which bar's got the biggest area. Now, look at face value and looking at it, it's a bit difficult to tell which bar actually has got the greatest area. You might think it's 160, it might be this one here, but the problem is, just because it's tall doesn't mean it's got the biggest area. So again, it's a little bit more controversial. You might think it's this one, but again, it's only until you actually physically work out the area of the bar will you know which one has actually got the biggest area. Now, the greatest feature of a histogram is to look at the spread of data to see how the data is distributed. And again, that's on a much higher level of statistics that you probably need to know depending on what level you're working at, but that is the main principle of a histogram. It's to look at the spread of data rather than seeing which one's more popular, like a pie chart, let's say. So let's just have a quick summary of when to use a histogram and when to use a bar chart. Now, when to use a bar chart. Now, you use a bar chart when you have categorical or discrete numerical data. And again, the definition of discrete is basically that numbers that can only be certain values. So in other words, whole numbers, I would say, for a bar chart. If it goes into, let's say, half size, and that's fine, but that would have to have a unique category for that. Also, that if you have got group data, the range of each group must be the same and numbers should not overlap. So that kind of goes into certain values. So for example, yes, you could have group data, but the group datas must be, it's like for example here, if I had 160 to 180, let's say, that if I had 160, what group does it go in? And there you go. And again, that's only if you can't have decimal numbers. So for example, you can't have, let's say, 60.5 and it'll just go into there. But I would say if you've got group data, just don't draw a bar chart. But again, it's easily done depending on what level you're working at. So, and again, you only draw a bar chart if you are asked to draw a bar chart. Now, this is sometimes known as a frequency diagram, which is absolutely fine. And I'll just add that in there as well. But again, a bar chart tends to be at a much lower level. Now, when do you draw a histogram? Well, again, you draw a histogram when you have got grouped and continuous data. And again, a refresh on what continuous means. It's that numbers that can be any number within a given range. Also, that group ranges are different. So it can be the same in some cases, but I would say the groups ranges generally are going to be different. And also, you draw a histogram when you are specifically asked to draw a histogram. And again, if you were asked to draw a frequency diagram, don't opt for a histogram, go for a bar chart. It's a lot easier and less strenuous on the brain. So only draw a histogram when you've specifically been asked to do so. Now, as mentioned about frequency density. Now, frequency density is what goes along the y-axis or the vertical axis of a diagram. So when you're drawing a histogram, the group data or your first column would go along the across the horizontal axis, along the x-axis, we should say, and it's frequency density that depends on the height of each of those bars. Now, as mentioned, one of the biggest differences in a bar chart and a histogram is that in a bar chart, the height is what represents the highest frequency, whereas in a histogram, the frequency is instead represented by its area. Now, because of this, rather than having frequency along the vertical axis, instead we use frequency density. Now, the formula to work out frequency density is this, and this is a formula that you are going to need to learn. So it's the frequency, which is basically how many are in that group, divided by the size of that group. So for example, if I had, let's say, 140 to 160, again, I should really be using inequality, so let's promote good presentation. Now x doesn't really matter, don't worry too much about what x is, and let's say, so let's go for height as an example. Frequency is 3. Now looking at this, my class width would be the size of this group. So in other words, it's going to be 160 take away 140. Now you'll probably be able to do that in your head, but if you ever struggle to work out the class width, then just do the upper bound, take away the lower bound, and that will give you the class width, which in this case is 20. Now the frequency is always going to be given to you, so the frequency density for this one is going to be 3 divided by 20. Now, once you've calculated the frequency density for each of your sort of rows that you've got, the next thing we then need to do is plot it. Now, again, your first column is what always gets plotted, or the group data always gets plotted along the x-axis or this axis here. And the frequency density is what gets plotted along the vertical axis, and that's always going to be the case. So now let's go on to actually drawing a histogram. So the best way to do that is by having an example and working through this example. So this example says that in a university javelin competition, one group of students recorded their throws, and the results are as follows. And the question is asking us to draw a histogram for these results. Now the method in which we do this is, now this is a typical setup of any sort of drawing a histogram question. You will get given a table which has got the groups and the frequency, and that is pretty much it. Now there's 2 stages to drawing a histogram. One is creating the data, and next is then actually physically drawing it, and you can't do one without the other. So the first thing you want to do, and I've written down some steps in terms of method, which is just along here, and I'll refer to these methods as we go on. So the first thing you want to do is create a class width and a frequency density column. So what we need to do is extend this table. I'm going to try and do it as neatly, and you probably recommend using a ruler, particularly if you're doing this as classwork, and try and be as neat as possible. And that's not too bad. And again, just being a slight perfectionist, let me just get rid of that line and do a little bit better. A bit like this. I'm going to create 2 columns. Now the first one I'm going to create is my class width, and the second column is going to be my frequency density. Now I'm just going to abbreviate those and use a cut. So I'm going to class CW and FD, but that's basically what it is. So the first thing I'm going to do is find the class width. So here again, if I'm not too sure, I should be able to do this in my head, but if I don't, it's basically the upper bound, take away the lower bound. So the first one is going to be 40, then it's 10, then it's 5, then it's 5, then it's 10, and then it's 10. And again, so now what you should find is that all the class widths should have a common factor. So for example here, a common factor between all my class widths is 5, but again, that's going into high level histograms of something you should be aware of. So you shouldn't just have random numbers, they all should be multiples of one general number, preferably not 1 or 2. So the next thing we then need to do is work out the frequency density. Now if you remember from the previous slide, so frequency density is calculated by the frequency divided by the class width. Now you might need to use your calculator for this, which is no problems at all. So again, for the first one, and again, one way to look at it is to do this. So I'm going to just divide both these two, the second and my third column. and that's going to equal those. So I've got 2 divided by 40, which is going to give me 0.05. I've got 9 divided by 10, which is 0.9. 18 divided by 5, which is 3.6. I've got 12 divided by 5, which is 2.4. I've got 16 divided by 10, which is 1.6, and 1 divided by 10, which is 0.1. And there is my frequency density. Now, in terms of representing this in an exam, that calculating this column would get you 1 mark and calculating this column would also get you a mark. So it is really it's definitely worthwhile to actually make sure that you are creating these 2 columns, not just doing your class width in your head, and make sure you are writing it down, because if you do make a mistake, it's kind of thinking of when was the last time you didn't make a mistake. And obviously this is one of the early stages of working with a histogram, so it's really important you do this correctly. Now the next thing to then, once you've completed the table, the next thing that you then need to consider is what scale are you going to be using. Now this is again one of the most challenging parts with anyone drawing a histogram, is actually drawing the actual diagram. Now for this, if I just get a highlighter, let's go for yellow, is you're going to be plotting this data against this data. And so this is what's going to go along the bottom, so that's going to go along the x-axis, and it's this column that's going to go along your y-axis. So when I'm drawing my scale, now for this, in terms of I need to use the smallest number to the highest number, so I need to go from 0 to 80, and going upwards, so that's my frequency density, and that is the throw in meters. And so for the going upwards, I need to go, now looking at this, I need to be able to plot 0.05. So I'm starting at 0 and the highest number is 3.6, and I'm just going to round that up to go to 4. So you kind of need to make sure that with any diagram, you want to try and make it as big as possible, but you also want to make it very easy for you to plot. So if you are using graph paper, maybe using one big bar as representing 1. So again, if I just go through like so, so you've got 1, 2, 3, 4. And then going from 0 to 80, maybe picking the smaller boxes and going up in tens may be a better option for you. But again, like I said, to make your life a lot easier, look at the numbers you've actually got to plot and then think to yourself, okay, in my scale, is it possible for me to do that? And that's one thing to move on to now. Then that leads us nicely as a segue into the second step, which is actually drawing the histogram. Now, in terms of the method, as we mentioned, that we need to choose an appropriate scale for both axes, using the first column in your first column of your table along the horizontal axis, and the fourth column, or the frequency density column, along the vertical axis on the graph paper. Draw each bar using a ruler, and again, presentation is key. It's got to be on point. You've got to make sure you be neat and accurate as possible. The next thing you then need to do is check that the group with the highest frequency must be the bar with the biggest area. So for example, if I go up, I can see that the group with the highest frequency was 50 to 55. So when I look at that bar has got to be the one with the highest area. It doesn't need to be the tallest, it's just got to be the one with the biggest area. Now you can see that's pretty close to 60 to 70. So again, it's a little bit controversial in terms of looking at eyes of which one's actually got the biggest area. Is it 60 to 70? Is it 50 to 55? It's a little bit there controversial, but that's something that you'll have to work out by working out the area of each of those bars. Now also bear in mind that although it looks empty from 0 to 40, there is a very thin slither of a bar, and again you just want to be trying to be as accurate as possible. And again, the whole point of drawing a histogram is not about showing which one's more popular, it's talking about the spread of data. And again, we'll lead this into another video when we discuss drawing conclusions from a histogram. Now again, in terms of the plotting, now the first group was 0 to 40, and the frequency density was 0. I think it was 2 or 1, 0.05. 0.5. Now for this, you can see that drawing 0.05 is going to be ridiculously difficult. Obviously one little box represents 1, so you're looking at half a box. So just try and go as close as possible. Obviously you're not going to be able to draw it with a huge amount of accuracy, but you want to just try and be as close as possible. And the examiners will give you benefit of the doubt when it comes to that. The next thing we then need to do, and again, it's always worth marking your groups out and then going upwards. Now again, I strongly recommend doing that first before drawing the bars and then going up there. And it's definitely worth checking. And again, a typical question I always get asked by my students is, do they really honestly check it? Like, do they just look at it and think, yeah, that's right? Or do they actually physically check? So if you're one box out, will you lose marks? Well, in an exam, probably yes, because how they mark these histograms is they have tracing paper the correct answer, they put it over yours. Does it match? Yes, full marks. If it doesn't, you lose marks because of accuracy. Now, the best way for you to practice drawing histograms is to do just that. So if you'd like, have a go at this question. You can see it on the screen. You might want to pause the video while you complete the table. So again, for this, the table shows the total time spent at a gym during 1 week by some members of a fitness club. Draw a histogram to represent the data. So again, the key principles are, and again, I'll just start you off, is you want to start by creating 2 columns. Doesn't matter how the width of those 2 bars are going to be. One of them is going to be class width, the next is frequency density. And again, you want to complete that table. And then from that data, you're going to then plot this against the frequency density. So again, in terms of your histogram, you've got frequency density going along the top, and you'll have 0 to 8 going along the bottom axes. And again, the key principles is don't forget to label your axes, including the units. And obviously frequency density doesn't have a unit, but again, just make sure you label it as FD or frequency density. So again, have a go at this question, complete the table and pause the video, and then when you restart, I'll go through the answers. So now let's have a look at the answers. So in terms of the tables that you should have, the class widths for the first group is 2, 1, 2, 3, and then the frequency density values are 16, 40, 24, and 15. Now, when it comes to drawing your histogram, again, we're plotting time against the frequency density. So looking at the scale, we've got 0 to 8 going across and 0 to 40 going up, and your diagrams should look exactly like you can see on the screen. Now, your scale might be different, but generally it should carry the same shape as what you can see on the screen. Now, there will be some practice questions in the description below for you to practice everything you've learned in this video.